Today we're going to talk about graphing inequalities in two variables. So instead of graphing on a number line in a one-dimensional space, we're going to be graphing on a coordinate plane in a two-dimensional space. So suppose your budget for a party allows you to spend no more than $12 on M&Ms and pretzels. M&Ms cost $4 a pound and pretzels cost $2 a pound. Find three possible combinations of M&Ms and pretzels that you can buy. So the first thing we want to do is define our variables. So what are the things that are changing in this situation? So let's let x equal pounds of M&Ms and y equal pounds of pretzels. Each pound of M&M costs $4, so we'll write 4x plus each pound of pretzels costs $2, so we'll have 2y, and this quantity needs to be less than $12 or equal to, so no more than $12. So now we have our inequality. So now we need to think about what are the different possibilities or possible combinations of M&Ms and pretzels that we can have. So let's just think about that for a little bit. I really like chocolate, so maybe I just want pretzels, so 3 pounds of pretzels and 0 pounds of pretzels, okay? Or I could have 2 pounds of M&Ms, and that would give me $8, and so I might have just 1 pound of pretzels, and I would still be within my budget. Think about 2 other possible combinations and write those on your paper. So we have our inequality. 4x plus 2y is less than or equal to 12. And we want to graph this. So when you're graphing inequalities, the first thing you have to graph is the boundary line. And the boundary line is going to separate the solutions from the non-solutions. And sometimes the boundary line is included in the solution set. So the equation we're going to graph is 4x plus 2y is equal to 12. Since this equation is in standard form, it might be good for us to use the x and y intercepts to graph. I also notice that each of the coefficients of x and y are factors of 12. So I could really make my equation a little bit easier by dividing both sides by 2. So then I would have 2x plus y is equal to 6. So that would be it's a lot easier for me to graph. So let's go ahead and look what's the x-intercept and the y-intercept. So if we let y equal 0, we can find where the graph is going to intersect the x-axis, and that would be 3, 0, because 2 times 3 plus 0 is equal to 6. And to find the y-axis or y-intercept, I'm going to let x equal 0 and y will be 6. So let's go ahead and make our graph. So remember that we want to have equal intervals on each axis, and we want to make sure that we label everything. So I think I have enough space to go by ones here, so I'm going to start at 0, 1, 2, 3, 4, 5, 6, 7. And this axis represents the pounds of pretzels. Oh no, pounds of M&Ms, sorry. And this axis represents the pounds of pretzels. And and we'll label our graph as party mix. So our x-axis is 3, 0, or x-intercept is 3, 0, and our y-intercept is 0, 6. And let's go ahead and create our line. We are going to use a solid line because it is less than or equal to. That means that the points on this line, the coordinates of these points, are solutions to our inequality. So let's think about that. In the previous section, we said we could buy 3 pounds of M&Ms and 0 pounds of pretzels, or 2 pounds of M&Ms and 1 pound of pretzels. So we could do 2, 1 would be a solution. Okay, so when you're working with inequalities, you need to find out which half plane is the solution. Either this side of the line is going to be the solution, or the left side here, underneath the line. So it's always good to choose a point and check to see if it's a solution. And if 0, 0 is not on the number line, it's a really good choice because it's really easy to multiply things by 0. So we can do 4 times 0 plus 2 times 0 is 0, and 0 is indeed less than or equal to 12. So that means that's part of our solution set. So is 1, 1. We could buy 1 pound of M&Ms and 1 pound of pretzels and stay within our budget. We could also buy 1 pound of M&Ms and 2 pounds of pretzels. And notice that 3, 0 is on our number line. We could buy 3 pounds of M&Ms and 0 pounds of pretzels. Likewise, if you don't like chocolate, you could buy 6 pounds of pretzels and be done. You could also buy 1 pound of M&Ms and 4 pounds of pretzels. So when we're looking at the inequality, we're actually going to shade in the area beneath the line, because that represents all the different combinations of pretzels and M&Ms that I can buy and stay within my budget. So let's try an abstract example. Graph y is greater than 3/4 x equals 1. So what we're going to do here is the first thing we want to do is graph the boundary line. So y is equal to 3/4 x minus 1. And I'm going to label my axes so I know which one I'm looking at. So when I graph my y-intercept, I'm graphing it on the correct axis. So our our slope, because we're in slope-intercept form, is 3/4, and my y-intercept is 0, -1. So I'm going to go ahead and graph 0, -1, and then I'm going to remember that the slope is the change in y over change in x, or the change in the dependent variable over independent variable, or the vertical change over the horizontal change. So we're going to go up 3 units and over 4. Okay, but this time when I graph the line, it's going to be a dashed line. And the reason it's a dashed line is because the points on that line are not included in the solution set. So let's think about what that means. If I put in a point that's on this line, so let's say this point right here, which is -4, -4. Actually, that wouldn't be right. Yes, -4, -4. So -4, -4. If you plug that into this inequality, so we substitute those values, and we have 3/4 times -4 minus 1. that gives us negative 4 is greater than, when we take 3/4 times negative 4, that gives us negative 2. And notice that this is not correct. Negative 4 is not greater than negative 2, so that's not a part of our solution set. So when it's a dashed line, those points are not part of the solution set, but they help us identify which half plane represents the solution set, or all the ordered pairs that fit x and y. So when we do this, we want to choose a point, and like I said in the previous example, 0, 0 is always a good choice. So if I substitute 0, 0 into the inequality, so 0 is greater than 3/4 times 0 minus 1, that gives us 0 is greater than negative 1, and that is a true statement right here. So that means that we are going to shade the half plane that is above the line. And so all the points, all the ordered pairs here in this half plane are solutions to the inequality. So now I'd like you to try the remaining problems on the note sheet. So you have one application problem, and then you have two problems to try. Remember, on this one it's in standard form. You might be able to divide by some number to make it a little bit easier.